Is it being recorded? Okay. Okay, so good morning, everyone. My name is Rodrigo Ventura. I am faculty at Instituto Superior Técnico and also researcher at Institute for System Robotics. Welcome to this short course on ROS programming on this 2020 edition. João Avelino, do you want to introduce yourself briefly?
Okay, so my name is João Avelino. I'm a PhD student of Professor Rodrigo and Professor Alexandre Bernardino, and I'll be taking care of the second part of the workshop on the afternoon, where we are going to address some practical aspects of ROS. And my main interests are human-robot interaction, machine learning, and computer vision and control.
Okay, thanks. My areas are intersection of artificial intelligence and robotics, with the focus on space robotics applications. So moving on, so this course is divided into parts. The first part in the morning, I will be taking covering more high-level and theoretical aspects of the ROS system. And on the second part, on the afternoon, João Avelino will take the floor and we'll go deeper on the details on the programming and using of the language and on some hands-on experience. So on this, let me recall that on this web page, you have some instructions if you want to download the virtual machine to try out yourselves during the this course, some of the materials. So we strongly advise you to do so. Concerning questions, so if you have any questions, you can put them on the chat and we'll try to answer them quickly. Otherwise, I'm okay if you want to unmute yourself and just interrupt and ask something. So it should not be a problem, okay? So, and before proceeding, we just like to have an idea of your background, and I will launch a poll. So can you see the poll? So just a question whether you have experience on this system. So Linux, including using the shell, whether you have experience with ROS, some previous experience, you know programming, Python programming and C++ programming. So I'll give you just about 1 minute for you to answer, just for us to have an idea of your background to adjust the contents. And while you are doing that, I will switch to the slides of the first part. So the slides are on the web page, and just to mention that this short course is organized by Institute of Systems and Robotics, me and João, and this is IEEE Robotics and Automation Society Portugal chapter event, and also an European Robotics Week event. So I will switch now for the first block of slides while you answer. Okay, I will also switch off the sound when people enter the room. And this is not the first slide, sorry. Okay, so I will stop now the poll. Thank you for answering. So we have now a good idea of your programming background, which is great. Okay, I think I can share the results. I don't know what you can see from that side. Well, this is not a voting. Okay, so João, can you see the result?
Yes.
Yeah, okay. So I'll stop sharing and let's go for the, so can you see the slides? Is it visible?
Yes.
Okay, thanks. Okay, so let's go. So in this first part, we'll be covering the more high-level aspects of the ROS system, more theoretically, if you want to say. But before, just to first tell you what ROS is. So ROS is called an operating system, even though it's not an operating system, it's like Linux or a Windows system. So it's operating systems in a broad sense of having a framework of libraries and software that can be used together in this case, being tailored for doing robot software, even though there is not much specific to robotics. So it's a middleware that can be used in many other applications, even though it was designed for that. So it was originated in Stanford Artificial Intelligence Lab, and now it's currently managed by Open Robotics company. It works in multiple operating systems, even though it really works nicely without any trouble on the Linux Ubuntu. So it historically became more specific to Ubuntu, and it can be used for many programming languages, even though the main ones are the ones that we ask you about. So Python and C++ are the main being used. Although there are bindings that allow you to use ROS from Java, JavaScript, C#, and even you can use it via WebSockets tunnels if you want to have. So you can have a web application that interacts with ROS using WebSockets, and you can have a web page, a browser that directly interacts with the ROS system, which is really cool. Okay. Now, ROS was not the first middleware that appeared. There has been others, but it was probably, I mean, the one that got a much larger user base than the others, become nowadays widespread use. And so it's, I would say that it's very hard to find a robotics lab, at least in the academia, that does not use ROS, because it has a huge large base. So there is lots of third-party applications and packages that can be used together with ROS. And I mean, fundamentally, it allows you to, with a very short learning curve, to have something working with the robot with some sophisticated behavior. Okay. So you have of course, you can Google for answers. There is this main ROS users forum that you can go for answers on that. Now, before proceeding, let me give you a big picture about what goes inside the computer. So in this course we are going to focus mostly on the software aspect. So things running on a computer. We are not going to talk a lot about specifics of robots. And so typically, if you have robots, you have a computer system inside a robot, and in this computer system, as I mentioned, Linux is the main operating system being used here. And what do you have inside the computer? So you have, going bottom up, you have the hardware. So you have the CPU, the memory, the devices. If you have a computer connected to a robot, you're going to have more devices that connect for actuators with sensors, whatever. And therefore, in the software, you have these two layers of software in Linux. So the kernel space and the user space. So in the kernel space, going up bottom up, you have the device drivers, which is all of the low-level software pieces that connect directly with hardware inside the kernel. So the kernel is the first thing that when Linux starts, that is loaded and starts being executed. And it has some architecture-dependent kernel code. This is code that is depending on the hardware, depends on the CPU that you have, depends on the hardware that you have. Besides that, inside the kernel, which is a monolithic, it has modules, but it is a chunk of the operating system. You have a bunch of hardware independent software, okay, which is process management, which allows you to have multiple processes running at the same time, okay, giving you the idea that you can run everything in parallel. I mean, in fact, it is not really run in parallel, but it is multiplexed in time. I'm not going to get into details of that. So managing processes, okay, managing memory, okay, allocating memory, virtual memory system. You can use the software can see more memory than the memory that really exists in our computer. Virtual file system. So in Linux, you see everything in the same file system, differently than other operating systems where you have, for instance, in Windows, you have the disk and then you have the folders. In the Linux, it looks like a single file system on top of which you mount individual file systems. So for instance, a USB pen is a folder inside this virtual file system. And then we have the network stack, which is everything that has to do with the networking. Okay, and all of this stuff is independent of the hardware that you're running on, and is something that nobody has direct access to it. Okay, how do we interact with all of this stuff? We interact through a system call interface, which is a set of functions that you call this kernel space. Okay, so this is privileged code, so it is code that is able to do everything with the computer. But the process that you run in Linux, they are constrained, so you cannot mess with the memory of another process, which is good because you don't have when something goes wrong with the process, that process dies and does not affect the rest of the operating system, and it is a virtue of a set of protection mechanisms that allow one process to mess with other processes. And so here in user space is everything that you can launch, run, start, stop, that you can visualize. So in user space, we have this C library. So when you start learning C, like the fopen, the fwrite, the printf, all of that stuff is in glibc together with all of many other functions, which is common to any Linux systems, and also shared with other Unix systems. And then you have all of the programs that you run in multitasking, so applications, the shell, and everything that is graphical in the X. So all of the graphical stuff is based on the X Windows system. Okay, and important to notice that in Linux, when you open a shell, okay, that's one process like any other. Okay, so everything that happens on the shell is limited to that shell. Okay, and so and the shell is just another application. Like the Chrome is another application, all of the other stuff is just another application. Okay, so here, take-home message is that all of these applications run in protected spaces. They can interact between them, and they are processes. Okay. So having said that, I mean, if you have any questions about this, just let me know before proceeding. So next slide is about ROS. Okay, so if there is no other questions, the curious. Okay. Okay, so in ROS, I want to stress that so in ROS there is three important concepts, which if you grasp those, everything else should be straightforward. Okay, so I will spend some time explaining these three concepts, which I believe are fundamental to understand everything. Okay, so the first of the three concepts is the concept of a node. Okay, and so a node is the mechanism that allows us to modularize ROS. So a node is nothing else than an operating system process. Those processes that I show you in the previous slide. Okay. So you start the process. Okay, and that the process that is able to connect with the ROS system is called a node. Okay, so a node is nothing else than a process that has some ROS capability. Okay, and so a node is a process which was I said. Okay, so and nodes connect and communicate between those. Okay, and basically that's what ROS is all about. Okay, is a very straightforward way to have processes communicating between them. Okay, let me give an example. So in a robotic example, okay, and so you have hardware. For instance, you have a rangefinder or you have a camera, and you're going to have a node that will talk with this device. Okay, and this node will abstract all of the details of that device, and will be the point of contact with everything else in ROS with that device. Okay, being it a sensor, being actuator. For instance, you have motors on a robot or a robotic arm. Okay, so there will be one node that represents in ROS that robotic arm, which is a driver. Okay, and so if you want to do anything with that arm, we communicate with that node. The punchline for the ROS is that the communication between nodes is very easy to set up and to make it work. Okay, and that is the big advantage of ROS. Okay, then this is core. Okay, now these nodes that talk between them, okay, they can be on the same machine, but they can also be in different machines, and all of that stuff is transparent. So you can have inside the robot, you can have multiple computers inside. We have done so in the past with robots with multiple motherboards inside the robot. And the thing is that the nodes, they can be on one seat, on one motherboard, on the other motherboard, in a completely transparent way. You don't need to do anything to change that. Okay. Now, one thing that I did not mention, all of this course is about ROS1. We are not going to cover ROS2. Okay, just ROS1, and this is only true in this slide for ROS1. Okay, how do nodes communicate between them? So there is one special node called ROS core or ROS master, which is the point of contact between the nodes. Okay, so for one node to communicate or to live in this ROS ecology, the only thing that it needs to know is where is ROS core. Okay. Okay. Once it is able to communicate with ROS core, it is able to access everything on okay. And so basically ROS core acts as a name server. This means that it maps names to nodes. Okay, so I have, for instance, imagine that you have one node that is responsible for localizing the robot. Okay, I want to get laser data. Okay, this node only needs to ask where is the driver, and it will communicate with it in a completely transparent way. Okay, and so you need this ROS core. Okay, so you can have, if you have nodes in different machines, you have to commit to have one ROS core in one node. Okay, you cannot have a ROS system with multiple ROS cores. Okay, however, you can have in the same machine have different ROS cores, but they will be isolated. Okay. However, it is also possible there are other nodes that can put multiple ROS cores in communication between them. Let me give an example. So one typical question is when you are doing multi-robot systems, when you have multiple robots, where should this ROS core be? Okay. So one possibility is to have the ROS core in external computer. Okay, which makes the system not so autonomous. But of course, once you have any network issue between the external computer and robots, you have a problem. Okay. Another setup which we have used in some years ago in the Monarch project, where we have multiple robots and we do not have this single point of failure, is to have each robot a single ROS core. So inside the robot, you have one ROS core, which all drivers communicate with, and then we can have, there are mechanisms that allow ROS cores to communicate between themselves. And so for one node in one single robot, it was as if you were a big ROS cloud, so to speak, even though you had multiple ROS cores talking together. Okay. The basic setting is a single ROS core, and then we have the nodes communicating between them. Okay. So I mentioned in the beginning, so the only thing that when a node starts, the only thing that it has to do first is to know where is the ROS core. How does it know where is the ROS core? There is a default, which is localhost port 11311. I think it's a default. So when you launch ROS core, you need to launch ROS core. It will open that socket, and all of the nodes will try to communicate to localhost that socket automatically. Otherwise, you can override that using changing this environment variable of the shell. Okay, so you open a shell. As I mentioned, a shell it's just another process, and you can change environment variables in a shell. So these environment variables will affect everything that is run thereafter. Okay? And when one node is launched, it will check this environment variable, and if it is different, if it is set to something, it will try to contact that ROS core. So this environment variable is the mechanism that allows you to have nodes contacting ROS cores other than the default one. Okay. And of course, environment variable, the scope on environment variable is the shell where it is defined. Okay, all of the children of that shell will share this environment variable. A different shell, of course, it will not. Okay, and so launching ROS core, it's very easy. You go to, if you have ROS installed properly, so if you follow all of the steps of the ROS installation, you just type ROS core in a shell, and it will launch. You have all of this information. And if you notice here, and can you see the pointer? You can, right?
Yes.
Yes, okay. So One of the outputs of the ROS core is this line over here that tells you where is the ROS master, okay? And so in this case, this is the host name, this is the port. So if I don't do anything, all of the nodes launched on this computer will connect automatically to this ROS core without doing anything. If I have a different computer, okay, if I set this environment variable on that computer, it will call this ROS core, okay? And just this is just copy and paste. You just need to type export this line, and it will allow you to connect to this ROS core, okay? Other than those multiple machines, you don't need to do anything. You just need to launch ROS core, and once I launch ROS core, then I have ROS, so to speak, enabled, and everything that follows will connect to this one, okay? Any questions about the concept of a node? Okay, the second concept is the concept of a topic. And the topic is the mechanism that allows nodes to communicate. In fact, there are two communication mechanisms, are topics and services. The topics are by far the most used ones. And I will try to show you the difference between these two and when do you should choose one or the other. Let's first focus on the topics. So the topics has this, so it's a communication mechanism that has this pattern. So you have a publisher, which is a node that sends message to a topic, and then you have subscribers, okay? And what happens is that every time one message is published by the publisher, this message is broadcast to all of the subscribers that are listening, okay? This is just like a mailing list, okay? You send a mail to a mailing list, the publisher is the one that sends a mail to the mailing list, and everybody subscribed to that mailing list will get that mail, okay? And this is the pattern, is a broadcast pattern, okay? And there are two roles. It is the role of the publisher, which is the entity that sends a message, and the subscriber, which is the role of receiving those messages. Okay, one published message is sent to all of the subscribers. Okay, and so typical question is can one process be a subscriber and publisher of the same topic? It can. Okay. Can you have multiple publishers? Yes, you can. Okay, so you can have multiple processes publishing to the same topic, and you can have zero or more publishers. You can have zero or more subscribers. Okay, you don't need to do anything to create a topic. Okay, there is no need to explicitly create the topic. The topic is implicitly created once you have one publisher that advertises the publishing, that is able to publish, or every time you have one subscriber that subscribes to that topic. Okay? So you can have zero or more publishers, you can have zero or more subscribers, and the idea is that this message is broadcast to everybody who is listening. Okay. Simple example: we have a laser rangefinder, we have a sensor, we have a camera, and the driver for a sensor, for instance, will be a publisher of data from that sensor. Okay, so if you have a camera, you start to a node which is the driver of the camera, which will interact directly with the camera using via the operating system, and the mechanism it has to send this data to the ROS ecosystem is being a publisher. So the driver is a publisher of camera images, okay? And then whoever is subscribed will get this image, okay? And so from the publisher side, you'll see that in the afternoon you will call a function to publish, okay? On the subscriber side, the typical pattern is that you have a callback function, which is you define a function, and every time the node receives a message from that topic, that function will be called. It's called the callback function. Okay, so it's an event that is generated and this function is executed. So for a sensor, you have the sensor being a publisher. For an actuator, is the other way around. So for instance, if you have a driver for a wheels of a robot, those drivers will be a subscriber, and the topic will be, for instance, the speed that you want the robot to execute. Okay, so when you launch the driver will create a topic, and this topic will convey a message of, for instance, wheel velocities, and whoever wants to command the robot, it will send this a message, and the driver will execute. Okay, of course, if you have in that setting, if you have multiple publishers sending different tool speeds, of course the robot will be confused, and maybe we'll do the average, but it is a mechanical average. Okay, and of course it depends on the driver. Also, in the as a note, typically in motor drivers, you need to publish regularly, and if there is no message for a motor driver within some milliseconds, you'll just stop for safety reasons. Okay, that is very simple. So you don't want your software, when you crash your software, you don't want the robot to keep going straight until it's something. Okay, so typically there is a timeout, and if there are not enough messages, but that has to be dealt by the driver. Okay, there is nothing to do with ROS. Okay. And so how can you see visual? I mean, the fastest way to visualize the topic is you can use a command line to publish something to a topic. So this is a command line command called ROS topic. More about that later. ROS topic pub, the name of the topic, the type of the messages. So the messages are typed. You need to define the type of the messages. And then in this case, it's a string. Okay, you have ROS node lists, which lists the topics that are there. Okay, and this is so before beginning, you only have this, and you do a sorry, I'm messing up. So this is ROS node list. So this is a command to list the nodes. Okay, this ROS topic is a program to publish something. I mean, it's a program that can be used for many things. One of the things is to publish messages to a topic. And it's a node, because only way that you have to communicate with ROS is being a node. ROS node list will list the nodes, and you have here this ROS topic is the default name of this node. ROS topic list is a command that lists the topics. See, this is 3 topics that are in this ROS system. ROS out are default ones, you don't need to worry about those, are created automatically by ROS, and you have here the name of the topic, XPTO, which is this name over here. And if you do ROS topic echo, it will print date over there, and it will print the LOL. Okay, so this is the most simple way that you can visualize a topic, creating a topic, or publishing to a topic, and subscribing to a topic. So this is the publisher, and this is the subscriber. Okay, you are going later on the afternoon learn how to do that programmatically. Okay, this is the command line. Although let me stress that these command line tools are extremely useful for debugging. Okay, so you can debug by sending message to some topic to test how this node will react, and you can inspect. This is used a lot. I mean, ROS topic list and ROS topic echo are probably the most used command lines in ROS to know, I mean, what's going on in ROS, seeing what data is flowing, whether there is data. More about this later. Okay. Are there any questions about the concept of topic before proceeding?
Rodrigo, I think I have a question.
Yeah, go ahead, Felipe.
So I'm not sure if I understood in the first command, ROS topic. So you are creating a topic, or are you implicitly creating a publisher node? What is the XPTO? Is the name of the topic or the node?
Exactly, good question. So ROS topic is a common. When ROS topic launches with this pub, it will create a node and will be a publisher of a topic. The topic is called XPTO /XPTO. That's the name of the topic. Okay. Once this node launches, it becomes a publisher of this topic, and it will send one message to that topic. Okay. Which message is that? Is a string message, with the singular world. Okay, and by being a publisher, the topic is created implicitly. Okay.
But as soon as you name it, you are explicitly creating it, right? The topic, I mean.
Okay, so that's the meaning of the word implicit to explicit. So what I mean by explicit is that you don't do anything other than publishing to create a topic. Okay, I'm not sure if I'm being very clear. And so programmatically it will be more clear. So programmatically you advertise being a publisher for this topic. Okay, being it the first one or the second, third, anytime you want to publish, you need to advertise, which is the operation that advertises you as the publisher of that topic. The first time one topic is advertised, it is created by the inside the ROS core. Okay, there is nothing special on this creation of a topic. Okay, once the first publisher will create this topic. Okay, I don't know if it was clear. And so,
Yeah, I think so.
sorry, I did not finish. So you have the advertise, which is I declare myself as a publisher of this topic. And first time you have an advertised topic is, so to speak, created. And then I have a second operation, which is publish, okay, which is when this ROS topic will send this message to that topic. What was that more clear?
Yeah, I think so. Thanks.
Okay, welcome. Okay. On the other side, on the ROS topic echo, you have one node that subscribes to that topic. Okay. There is one operation which is subscribing. I want to listen from that topic. Okay. And then once the message flows, it will be called. Okay. There is one very small detail here that I'm skipping, which is the ROS topic pub. There are two kinds of topics. There are the latched and not latched. Okay, and the detail is that when you have a latched topic, okay, every time you subscribe, you get less message. Okay, and by default, ROS topic pub will create a latched topic. Okay. That's what it's here, publishing and latching message. Okay, and so when ROS topic pub runs, it creates a latched topic, sends one message, so that when the ROS topic echo subscribes, it will get the message that was published before. Okay. In non-launch topics, that will not happen. Okay. Okay. Any more questions?
Yes.
Yeah.
I have a question.
Sure.
So if I understand correctly, a topic is also a node, but not all.
No. Big difference. No. So the node is the process that interacts with ROS. The topic is the communication mechanism. One node can have multiple topics, can be publishing to multiple topics, and can describe. So there are two different things: topics and nodes. Okay.
So, but there is a node associated with a topic also, always.
At least one. But you can have multiple nodes associated to that topic. Okay.
So every message is a node, or every publish?
No. Node is the process that is running. Okay. Then you can have 1, 10, 100 nodes. Then you can have topics. Okay. And topics make the connections between nodes. It's like you have like a network. Okay. You can have multiple topics, multiple nodes publishing to the same topic. You can have one node publishing to multiple topics. So are different mechanisms. Okay, and so the topic, this square over here, it's not a node. Okay, it's something that is created. Okay, and then you have messages flowing through the topic. Okay, do you see the idea? If you want, the only place that you can see where are the topics are maybe on the ROS core. So the ROS core stores all of the topics that are running. Okay, so the ROS core has a list of topics. Okay, that's one of the places where you can maybe visualize the topic. Okay, and so when you have multiple nodes publishing to a topic, they are all on the equal in same footing. So there is no special. There is no owner of the topic. Okay, nobody owns the topic.
Okay, so the node is essentially the process of communication. Okay.
Yeah, just
okay. I understand. Thank you.
Okay. Any more questions? Okay, the third concept is the service, which is also communication mechanism. And so, but the service works in a different way. While topics, there are messages flowing from publishers to subscribers, the services, it's something that you call. Okay, it's like calling a function. Okay, and so a service is the mechanisms that for each you send a request and you get an answer. Okay, and so it has this design pattern of a request response. Okay, so a service is something abstract, just like topic that is managed by the ROS core. Okay, you need one server. Okay, you cannot have multiple servers for one service. You can only have one server, which is a server. It's a node that serves that service. Okay, and then we have clients. You can have multiple clients. The client sends a request to the server does something and then answers back to the client with the response. Okay, it's just like calling a function. The only thing different from a function is that you are calling functions between different processes, different nodes, and you can have a service and clients in different machines, and you can call functions services in different machines in a completely transparent way. All of that is managed. In fact, from the programming point of view, a service will be a function. Okay, so there will be a function that when you call that function inside the program, under the hood, the service is called. Okay, and then you get the return value of calling that function will be the response of the service. Okay, programmatically you see services as functions are called the proxies. Okay, proxy functions. So you send the request, the server processes, and again you get the response. Okay. Now the big question is, what is the difference between topics and services? Okay, and so one difference is that in topics you just data flow from one point to the other. Okay, while services you call something, you get something in response. Okay, and so examples, typically everything that has to do with streams of data, like camera images, laser data, comments to motors. So all of those situations where you are just flowing data, streaming data, you should definitely use a topic. Okay, topic, they are very efficient. Okay, in fact, even though in this picture I put everybody connecting to the ROS core, in fact, under the hood, the data flows directly from nodes to nodes. It's peer-to-peer, so it's extremely efficient. Okay, and that's when you should use a topic. You should use a service when you want to make sure that something is done. Okay, here I have this example of, you imagine that you have a self-localization system running in a node. Okay, and you want to reset it. Okay, the robot got lost, and just start over from the beginning. Let me give you a new location. And so that operation of resetting localization algorithm should be done by a service, because it's something that you send a request, and then you get some guarantees that that request is executed. Okay, every time that you need to make sure that your message was heard, use a service. Okay, the services, while topics are very efficient, services are slow. Okay, and so you should not rely on services for time critical things. Okay, services, they have a bureaucracy involved, and so they tend to be slow, but they guarantee something is executed. Okay, so every time you want to do something, okay, which is not done periodically, and you don't care so much about the timing, you should use a service. Okay, and that way you have a guarantee that your service was served. while if you want to flow data, then you have the topics. Okay. Okay, so here is a simple example. So we have ROS service. Yeah, Danielle.
Can I just ask a
Sure.
question?
Sure.
My question is, can we view services in the as like a TCP versus UDP messages? Because you services are like reliable.
Yes. Yeah.
Do we have this type of guarantees, or is completely off?
Yeah, I mean that comparison is a little bit dangerous because in fact, by default, the topics use TCP also. Okay, so comparing,
Okay.
but I mean, it's true that for topics you won't have any guarantee that the messages are received. Okay. In fact, something that might be frustrating when you first use ROS is that when you try, for instance, it might happen that I think that if you start if you start the subscriber first, and then when you launch the publisher, sometimes the first message is lost. Okay, because when the publisher is launched, okay, there is some bureaucracy being happened, and the message is might be lost. That way around or the other way around, I'm not sure. Of course, the latch sorts of fixes that problem. Okay, so there is no guarantee that messages are given in the topics. In fact, for instance, imagine that you have a camera flowing like 30 frames per second, and if you have a program that only processes 1 per second, of course you are going to lose messages. In fact, in the subscriber side, you have a queue of messages. Okay, and everything that falls over the queue, it's gone. Okay. That does not happen with services. Services, you have a guarantee that you get a response. Okay. Also, when you publish anything, it is not blocking. Okay. So your program just continues. Okay. In services, by default, your program is blocked while the request is being served. Okay. There is, of course, an option that allows you to be asynchronous. Okay. But by default, your program is blocked waiting for the response. Okay. If you don't get the response, of course, you don't have a guarantee of anything. Okay. Any more questions? So is it clear, Danielle?
Yes, yes.
Any more questions about services?
Yes, I have a question.
Sure, go ahead.
Just to understand better, I mean, in the case that, for example, you need occasionally a topic, for example, like you have a camera that is, you only want it, like, I don't know, every 10 minutes you want an image or something. Is it, I mean, if you use topics, are you flooding continuously, you're receiving messages which you're not using, or is it better to use service in this case, or you use the topic and then, yeah, so this is my question. When would it be better to use the services or topics?
So the case that you're mentioning is that you need one image from a camera in a very infrequent way, like 1 per minute or something like that.
Exactly, yes.
Okay, okay. I think that looks to me more elegant to use topics and then subscribe whenever you need some image, and then just disable the subscription, because that issue of getting one image, if it is on the consumer part, I would say don't change the producer part. Okay. So if you have a camera, and if your producer of data is a camera driver, I would say use the most natural way, which is being a topic. Okay. If you have one special node that in particular only needs one image from many times, you should be a subscriber. But if you don't want to flood the network, then I would say just disable the subscriber while you don't need it. Okay. You can set up, for instance, a queue of 1, enable the subscriber, get one message, then kill it. Okay. I think it's more cleaner than using a service for that. Okay. We are going to have, for instance, I mean, if time is critical, we're going to have some latency because of all of the encoding that happens on these services. Services should not be used for lots and lots of data.
Great, thank you.
Welcome.
Rodrigo, I have another question about topics.
Sure.
So in topics, do we specify which information or which type of information do we send, or can we send anything?
It's the following slide. I'll talk about that right ahead, which is the message types. Any more questions about services and topics?
Excuse me, I have another question.
Go ahead, yes.
You said that one of the mechanisms doesn't go through the ROS score. Which one of them is it?
Sure. So the topic. So the topic involves ROS score just to know who is which. Okay. I have a slide later on that will give you a very detailed picture of what's happening under the hood. But in the topic, data flows directly between nodes. Okay. For the services, that's a good question. I'm not sure. I'm not totally sure, but I think it's also direct between them. Okay. João, do you know this by heart? Whether services is also peer-to-peer?
I'm also not really sure about it.
Okay. I suspect that it is peer-to-peer in this because ROS score is not really something to transmit data. Okay.
Yeah, I guess everything is peer-to-peer. ROS score only says, okay, so there is this node which is expecting data in this port. There is this node also, and then connect to each other through TCP.
Yeah.
Or UDP also. It's also possible.
That's true. That's true.
Okay, so the ROS score only does the mapping?
Yes. Yes.
Yeah. Okay.
Yeah, in general, yes.
That's why I said here that this is a name server. You see. So
okay. I thought that it was like a bridge for communications.
Okay. No. Fortunately,
okay.
Fortunately, it's not. Okay. And so it just tells who is which. And so I'm not totally sure, but I will say 90% confidence that the ROS score is, so a client will ask ROS score who is servicing this service, and ROS score will tell that the server is in this TCP IP port, and then the client will call directly the guy. Okay.
Yeah. Okay. Thank you.
Okay. And so what happens in the mention that the example that I mentioned with multi-robot system when we have an external ROS score, it is not true that when the ROS score dies, the system just dies. What dies is that you cannot publish new topics, nor subscribe new topics, nor create new services. But the system that already set up there tends to live on a little bit more after the ROS score. Okay. So basically, ROS score tells who is which, and then everything is peer-to-peer, and then we have this network of nodes connecting directly between them. Okay. Any more questions? Okay, now the question of what flows in the topics and services are messages. These messages, they have types, okay? And the types of messages are defined in a programming language independent way through these text files. And here I have an example of a message type that corresponds to a laser, okay? This is a text file, and this text file is compiled into sort of include files for Python and for C++. Okay, and so in Python, you are going to see messages will become classes. Okay, and in C++, the same thing will also be classes. Okay. One message type is a class, one message will be an instance of that object in Python and in C++, okay? And so a message is simply a data structure with fields, okay? And I will talk about this one later, the header. And so here there are multiple fields. This is laser rangefinder. So if you don't know, so laser rangefinder, we have a laser, we have a mirror, and then it shoots beams all around, and then you are able to measure distances. And this is what you see top down. So you have this laser, you are measuring these distances, and what you get is this set of points. So for each laser angle, you get 1 point, which is one distance and one bearing from the sensor. Okay, so this is what the laser looks like. Okay, every time the laser does one scan, it will publish a message. So a laser rangefinder node or lidar, it's the same thing. Every time it has a scan, the driver publishes was message with all of these points. Okay, and so this is the data structure that you get in one message. Okay, you have angle mean, angle max is the minimum maximum angle of this laser. Angle increment is how many radians you go from one laser shooting to the next laser shooting. And then you have this is not much use. Time increment, scan time also not very relevant. Then you have this minimum maximum range, okay, which is the minimum laser distance and maximum laser distance. And this is used, and this is important if you're using laser, is that any measurement outside of this range you should discard because it does not make sense, okay. And so this is used for filtering laser data. And then you have here an array of floats, which are all of the distances. And then in some models of laser rangefinder, we have also the intensities, which is the reflectance of the target of the laser. Okay, so all of these are float 32. This is data type, and this is the name of the field. Okay, I think it's pretty much intuitive. And then with this notation, you create arrays. Okay, which can be bigger or smaller. Okay, not dynamically. Oops, sorry, dynamically defined arrays. Okay, and then so this is a basic data type. So in message we have basic data types. We have integer, you have strings, you have floats, and you have a bunch of those basic types. Okay, you have arrays of types, and then you can have types that are defined on top of the other ones. And the header is one of those cases. So a header is one message type that can be included in this message type. Okay, so you can have message types in a nested way. You can have message types for each one field. In this case, it's the header. This field of this message is of type header, which is another kind of message. Okay, and I could have another message type with this laser data inside. Okay, so it can be nested. So you have basic types, the floats, integers, strings, and so on. And you can have, and then on top of that, you have messages, which are another more types. Okay, and so one very important message that I want to say here is that please try to use the message that already defined default on the ROS, because ROS comes with tens of messages. Okay, this is very important. For instance, if we have different laser modules, even different laser message types, it will be a mess, meaning that if you change the manufacturer of your laser, you need to change your code. Okay, so it's very important that all drivers for laser rangefinders, they use this same message type. Okay, this message type is defined by ROS when you install ROS. And so ROS is divided in packages. We're going to see that later. Okay, so there are multiple packages, and these messages are defined in some packages. And I need to say that because these sensor messages is a ROS package. Okay, that contains lots of messages for sensors. Okay, and so any one of those sensors, okay, any driver of those should use those message types. Okay, so a driver for laser should use this one. A driver for a camera should use the image data type, and so on. Okay, magnetometers, you have initial measurement units, you have a bunch of those. Okay, also you have another package which is the standard messages, which are messages, trivial messages. For instance, you have message types only with an integer, you have message type only with one float, and so on, or with one string. And so if you want to have a topic doing something specific to your program, so if you just want to send an integer from one node to the other, don't create a message for that. Use the integer message type. Okay, so make sure that you check when you want to create new nodes, make sure that you check whether there is a message that fits your purposes. Okay, why I'm saying that? Of course, keep it simple, okay? Also, if you, so you can create your own message types, but every time you do that, you need to add something to your build system, so you need to compile those, okay? If you use one already existing message type, of course, it's simple, just use it and everybody will know, okay? And so, let me, okay. I don't have it here. So João, make sure that you maybe in your part, you list, make a ROS message list to show, just to show everybody the amount of messages that types that they are already available, okay?
All right, all right.
Okay, any questions about message types?
Sorry, I have a question.
Go ahead, yeah.
From a higher point of view, for example, you have the LiDAR and you have your robots, and you from what I understood, you want a topic from your LiDAR to your robot, correct?
Mm-hmm.
So so you have the LiDAR must be a node, correct?
The driver will be a node. The driver is a node that interacts with the LiDAR, which is the hardware part.
Okay, so you need to have like a processor in the middle of the LiDAR and the main processor, and the topic is between the main processor and that processor.
I'm just
correct?
about software, just about processes. Okay, so you have imagine, so these LiDARs typically are USB. So you have a LiDAR, piece of hardware, you have a USB cable connects to your computer, USB. In the operating system, the USB will identify, well, I have this port over here. It typically is like a serial port kind of stuff. And then you have one node, which is a driver. The node will connect to the USB port through this device, and will create the topic to send the laser data. Will be a publisher.
Okay, thank you.
Welcome. So once you start the drive, it will start streaming that, okay, which is on a node. Okay, so drivers are nodes. I did not mention, but when you advertise a topic, you tell which message type you want to send, okay? And same thing for the subscriber. When you subscribe to a given message type, okay? You can, in principle, have different message types on the same topic. It's not a good idea, but as far as I know, it's possible. You can have one topic and you can have publishers with multiple data types. Typically, it's not a good idea, okay? Try to keep topics always with the same message types, okay? So any more questions? Okay, so next I'd like you to give a picture of how the things go under the hood internally, okay? I'm not going to enter into details, but I believe that if you understand how the data flows, it will be more clear to you how it works, okay? Let me walk through this example. So here on the top you have, so these blue ovals are nodes. So here is the ROS core. Okay, this picture is taken from the tutorials of ROS, which I advise are very good. So you should do the tutorials to know more and got more experience. So this is the ROS master, the ROS core, ROS master, same thing, and so it's the first thing that appears in ROS. And in this example, you have here a driver for the laser rangefinder or QU, and here you have a viewer. It's like a graphical interface that shows in a graphical interface in a window the points from the laser. Okay, let's see how it works. So the first thing that happens is that when the driver launches, okay, when you start the driver, it will advertise the topic, okay? And this advertisement will be a communication with ROS core, okay? And it will tell you that I am advertising this data. Scan is the name of the topic, so I am publishing to the topic scan, okay? And I am here. Foo is the host name where the driver is running, can be localhost, and this is the port 1234, okay? And this tells, so everybody that wants message from me, contact me here, okay? It's my address, okay? And the master will store it in a list and know that for the topic scan, okay, you should contact this guy. If you want data from scan, you need to contact this guy, okay? The other thing that happens can be before or afterwards is the subscriber part. So this, you have a viewer, you have a window wants to show the laser data, and it will subscribe to scan. And it will ask master who has scan data. So subscribe scan is a message that is sent to the ROS core and tells me, please tell me who has laser data. And if this happens after this launch, okay, then it will answer immediately with, please contact foo at 1234, okay. If this is launched first, it will answer an empty list, but whenever this guy appears, it will send a message telling that, oh, now I have these guys publishing, okay. And this interaction is what makes sometimes you to lose the first message from a topic, okay, is this interaction, because if the viewer is launched before the publisher, okay, if the fan launched before the publisher, you have some latency for the subscriber to know that you have this new publisher, okay. And now let's forget about that. Let's imagine that first you launch the driver, then you launch the viewer. So the driver will tell you that I'm publishing to scan, and this is my address, my home address. Oops. And the subscriber will tell, please tell me, will ask master, tell me who is publishing to scan, and the answer will be foo at 1234. From this point on, everything will be peer-to-peer, okay? So this is the only interaction, and as you can see, answer the previous question, master is just a name server that tells who is which, okay, and manages that in real time, okay? This messaging is done with this protocol called XML RPC. So XML, it's extensive markup language. If you know HTML, it's very similar. And RPC is remote procedure call. So it's a protocol built on top of XML that allows you to call functions using XML, okay? I mean, you have a latency for parsing because XML is basically text file. And so you need to parse, and even though the parsers are fast, it's not as fast as raw data, okay? So this is why this communication, it has some latency that you should be aware of. So once the subscriber knows about foo 1234, of course, it will contact him. And so it will connect to the foo 1234, and you'll ask me, so where is scan data, okay? So master told me that you have scan, where do we have it, okay? So it will connect via TCP and ask where is scan. And the publisher will answer with, well, it's on this.
Eu já lhes disse, mas eles dizem.
Hello, is there an open mic, Tiago? Okay, thanks. And so the publisher will answer the subscriber telling him, well, if you want the data, please contact me at this port, okay? And so this first message exchange is just to know where is the TCP port where you have this data, okay? And so the viewer will ask, well, where is the scan after all? And the publisher will tell him this different port, okay? Notice that this port is different from this one. The port 1234 in this example is just for this bureaucracy stuff, it's for administrative exchange of messages, but the real data is on the other port, okay? And so, the publisher will answer to the viewer telling that, okay, so in this port 2345 is where you have the real data, okay? And finally, then you have a connect for 2345, okay? So the subscriber will connect to the publisher to this port that was given before, okay? And now the laser data starts flowing, okay? No questions asked, just streaming of data, okay? And this is what makes the ROS so efficient, is that the communication between the publisher and subscriber is direct peer-to-peer custom messages, okay? So this is binary data, okay? So no XML here, so it's very, very efficient, okay? This data flow in this example is TCP, but can also be UDP, okay? So if you, and might be critical in some cases where one typical case where this is interesting is to avoid congestion, okay? So if we have, we have experienced that very recently. We do some teleoperated robotics, and when you are teleoperating a robot, typically you have a camera stream, okay? and as your robot goes far and far away, the connection degrades, and you start losing packets. And since the default is TCP, it starts accumulating, and then you get congestion EC-cell. Okay, that's a good case where you should switch to UDP, because when the network degrades, you lose those messages and you are okay. Okay, so you can choose when you subscribe, you can choose whether you want to connect TCP or UDP. Okay, one more just one parenthesis. So as I mentioned before, this course is about ROS 1. ROS 2, this picture will be very different. Okay, ROS 2 revamps the whole infrastructure of ROS. ROS 2 gets rid of the ROS core, okay, and uses an industry standard called DDS. Okay, also because ROS is very popular in academia, not so much in the industry. There is some push towards putting more and more ROS in robotic application in the industry, and using this DDS is one way of getting more acceptance, because DDS is well known in the industry, while the ROS 1 messages are just custom made. Okay, so they don't have the certifications of that DDS. Okay, just this parenthesis. ROS 1, this is a picture that you have. Okay, and so also all of the ROS service happens at this level of the XML RPC. Okay, so you don't have the speed that you have with this direct connection. Okay, so any questions about these internals?
I would just like to add something. So the at least from my experience, I don't know if that changed now or not. The UDP transport is possible if you are using C++. At least in Python, it's not working well right now. So if you want to use UDP, then you have to all nodes, all the both communicating nodes need to be C++. Also, another interesting thing, as Professor Rodrigues said, no questions asked. So if you get inside the network and you know the IP of the ROS master, you have access to the whole ROS network. So there are some security issues here.
Mm-hmm.
If you take your robot somewhere else, please keep that in mind.
One way to solve that is by doing SMVPN or something like that. Okay, so ROS does not handle any authentication. Okay, it has to be external. One easy way of doing that is just create a VPN, and then you can encrypt, you can do everything you want. Okay, but once you get into a ROS network, you can do whatever you want. There are no protection mechanisms, there are no read-write privileges, so all of that simple, it's not there. Okay. Any questions? Okay, moving on. So in terms of development, of course, João will dig into this in much more detail. Just give you a view. As I mentioned before, there are two major languages that are directly supported by ROS, C++ and Python. Okay, of course, all of us might have different opinions about one of the other. So C++ is very, very speed efficient. It's very close to machine code. Python, on the other hand, is not so fast, but might allow you to do faster prototyping. And so I usually see Python as a rapid prototyping language. Allows you to set up something running in very short amount of time. And you can connect between C++ and Python if you want, but of course Python is not as fast by default as C++. And so you should choose wisely which language you want to do. Of course, different nodes can be in different programming languages, okay, apart from details that João mentioned of the access to the UDP. Apart from that, make a wise choice which you want to choose bidding or either. I mean, my advice, but of course it's my personal opinion, if you want to do prototyping, use Python. If you have some time critical aspect in your system, you should consider switching to C++ or implementing C++. But of course, as in all programming, and it was Donald that used to say that don't optimize your code prematurely. Okay, that's the source of all evil. The code is something like that. Okay, so you should only optimize your code on the parts that are time critical. Okay, don't waste time trying to do fast code when that is not time critical. Okay, for that it's more important to have an elegant, well-structured program, because if you want to optimize, sometimes it tends to get a little bit hairy. Okay, now this build system is most relevant for the C++ part. It is the current one is it's still Catkin, isn't it, Ron? I might be outdated. It's still Catkin.
Yes, for ROS1 it's still Catkin.
Catkin, okay, for ROS1. So before like what 5-10 years ago, it used to be ROS build. When I worked hands-on with ROS, I used to use ROS build. Not really got so that much used to Catkin, but nowadays Catkin is perfectly universal and you should use it. Okay, what is a build system is that you don't need to write your own make file. So the build system is built on top of CMake, and you have it's very easy to create a CMake file for ROS, for ROS program, and then just compile it, and it just automatically interact with ROS system. So it allows you to compile your program without getting into messy parts of linking, compiling, all of that stuff is annotated for you, which is cool. Package, as mentioned before, package is the mechanism for encapsulation of sources, data files, and building systems. So everything is packages. When you do one project for ROS, you need to create one package for doing that, and João will tell you all about how to create these packages. Okay, and the package has all of the source, data files, and so on. Of course, as your project gets bigger and bigger, it's typically the idea to split it in different packages, and typically modern complex robot systems. I mean, the VZ robot of João Velino is managing, the Monarch, the Sokal Petrom, all of that. You have multiple packages for different things, and many times you have different people assigned to managing different packages. On the ROS side, when you install ROS, you get a bunch of default packages. Okay, the message types are also divided in packages. So you have standard messages, which is a package for the standard messages. You have a different package for the sensor messages, and we have different packages for different things. Okay, and so everything is a package. Okay, and that's the way. For instance, and it's the way that you can exchange packages. So for instance, if you want to use a localization system, you need to use one package which does localization system for you. Okay, so it's the way that you encapsulate source and data, and it's the way also that you reuse code. Okay, is to have a package. Okay, and so as I mentioned, so the code reuse unit are packages. Okay, so you reuse packages. Okay, in different projects. Okay, that's the pattern. Okay, so you have a large variety of packages that can be found on the web. You have maybe too many or too much. So when you use packages that are not standard, be very careful. Make sure that they are maintained. You have a big amount of packages that were done once and they are not maintained, and so you should be very careful. So ROS, the ROS web page has a curated list of packages. Okay, and so that's a good way that you can know whether it is thirstwhile or not. Not all of them are there, but the main ones are there. Yeah. And so examples, so sensor drivers, packages, simulators, packages, simultaneous localization mapping, you have packages for that. Image processing, you have a package for that. You have a package for everything. Okay. Okay, so let me go briefly. I believe that João will go into more detail here. So you have a set of command line tools that are mostly used for debugging, are very useful. So one is ROS nodes. ROS nodes have these subcommands. So this is not an exhaustive list, it's just one, most important one. So ROS node ping, just to check whether a node is alive or not. ROS node list to list all of the nodes that are alive in one system. ROS node info tells information about the node. This is very useful because with ROS node info you can know when node what it is subscribing, what it is publishing, and what are the services. Okay, so all of those details are given by ROS node info. So very, very useful. ROS node machine lists nodes running on a particular machine. So if you, or list machines that are, if you have different computers in the same ROS ecosystem, you can kill a node by ROS node kill. Okay, it might be faster than doing a PS and to see the PID and copy and paste PID. Just can ROS node kill name of the node and you kill it. ROS node cleanup to purge registration of unreachable nodes to clean up stuff. Okay. ROS topic is the same thing for topics. So everything about topics is here. So ROS topic BW will display how many bits per second are flowing through that topic. You also have this HD, which tells how many messages per second are. So this is very useful to know if the topic is alive or not. Okay, if you have 0 messages per second, or if you have multiple messages per second. ROS topic echo will print messages to the screen. Okay. ROS topic find will find the topics by type. Okay, so it tells who is publishing laser data. You can do that. Okay. ROS topic info, very, very useful, tells you everything about the topic. In particular, ROS topic info will tell who is subscribing and who is publishing to that topic. Okay. Oops, sorry. ROS topic lists, of course, lists all of the topics. ROS topic publish allows you to publish from the command line to a topic. ROS topic type tells you the type of the topic. And something similar for service is also node arguments of the service. So while in topics, in principle, you can have different types for the same topic. For services, service has to have a single type because you only have one server. Okay, so you can have the arguments for the service. You can call a service from command line if you want. Find services by service type. Info, get all information about service, mainly who is serving it and the message type. ROS service lists the services that are being served. ROS service type will print the service type, and ROS service URL will print the URL, so the hostname and port of that service. Okay, so these command lines are very, very useful. However, you have some software. You'll talk about that later. There are more visual ways of visualizing this data. Okay, and so more about that later. Okay, so very, very important is the ROS bags facility. This is amazing. This is really cool because it solves one long-standing problem in robotics, which is data sets. Okay, so you have a robot, doing something, and you typically a pattern is there to record all of the data to process later on. Okay, so for instance, imagine that you are developing a localization system for a robot. Okay, so common pattern is that you go there, you take a data file of laser range finds over a trajectory of the robot, and you go home and try to debug your program over there. Okay, and so ROS allows you to do that very, very easily. Okay, and that mechanism is called the ROS bag. Okay, so ROS bag allows you to record into a file all of the messages from a set of topics. Okay, not only that, but also when those messages were published. Okay, and so it's like a record of everything that's going on ROS. Okay, and so the ROS bag record, when you launch ROS bag record, you specify whether you want all topics being recorded or only a subset of topics. Okay, and it records into the data file the messages, the topics, and when they were published. Okay, into a data file. Okay, extremely useful. It's like a snapshot. You don't need to do that code for that. Okay. And now what you can do is to play back the bag. Okay, what is a playback? Playback is, and this is the amazing part of ROS bag, is that the ROS bag will create the same topics, okay, and will publish to those topics the same message that were recorded at the same time instances. Okay, so it's like a playback. Okay, and this is amazing because from the software perspective, you have no idea whether the message is coming from a ROS bag or from a real robot. Okay, which means that if, as you are developing a localization system for a robot, okay, you are getting all of this data exactly the same way, coming it from ROS bag or coming it from a robot. Which means that if you have your software running for the ROS bag, you don't need to change one line of code, and it will should work for the real robot. Okay, and this is extremely useful. And let me give an example. So I give a course, Autonomous Systems, which is a project course. where students they need to develop during a semester either localization system, a SLAM, or a mapping system. And there is a limited amount of robots that they can use. And we always tell them, please go to the lab, record your ROS from robot, and don't mess with robot anymore. Okay, and they can do the whole project based on ROS. Typically what happens is that they get ROS in the beginning of the course, and then in the middle, close to the end, they get more ROS, which is for the final results of their project. Okay, but the punchline is that you don't need to have to, for instance, for those projects, you don't need to have your software running at the same way with the robot. Okay, you can get the ROS and you can show how good your algorithm is with ROS. Okay, and they are completely representative of what is going on. Okay, of course the catch is causality. Okay, you can record topics, but you cannot record you cannot actuate on the robot. Okay, so of course it works for localization projects. It does not work for control projects, because in that case you need to interact with the robot. Okay, and so but there are more. Okay, so you can play back in slow motion if you want. You can play back fast. You can go. You can do all of that stuff that you can do with the back. Okay, so ROS backplay is very flexible on that. Okay, and it is very useful and interesting. Okay, and so the how do you interact with ROS back? You have the command line called ROS back, and you have these subcommands. So check, compress. So compress and decompress. Why they are here? ROS while ROS is recording, it is totally focused on being efficient, being very, very fast. Okay, because if ROS has some latency issue, it might lose messages, and that is not good. Okay, and so typically the data file is recorded without any care about using space. Okay, and so when you do a ROS compress, you typically get as much smaller ROS. Okay. And you can also decompress if you want. You can filter, so you can filter ROS, meaning that you can have a ROS and you can get a second ROS with only a subset of topics if you want. You can fix fixes if the ROS for any reason crashes. If the router crashes, the ROS becomes corrupted, and you need to ask it to fix it. Help is a list of messages. Info is information about the ROS. So when was it recorded? Play to play, record to record. And Linux, I'm not sure what it does. I think it has to do the same with fixing, but I don't know the details about that. Okay, so ROS very, very important tool for getting data from the robot, for developing, but of course does not help you if you want to do control. Okay, any questions about ROS?
Hi, teacher. I have a question in the previous slides because of the communication.
Which slides?
Because in the communication,
this one.
It's need a physical internet connection, because I have an application, but communication is scrambled without internet connection.
I'm not sure what do you mean by that. I mean, you need to have connectivity, being it physical or wireless. You need to have IP connectivity between them. So the bare minimum that you need IP connectivity. This means that machines need to have an IP address.
Yes, but don't need the internet connection physical because of the clock?
Of the clock?
Yes, because the internet, the term of the message.
I mean, the timing of the messages, they use the computer clock.
With the computer clock, because you have the application, you have two computers, because one computer control of the arm of the robot, your computer control the mobile robot. Because I have two computers, I need the physical connection.
Oh, I think I can help on that, because it also happened on Visi. So for instance, we have a laptop that is connected to Visi, but we have no internet whatsoever on the laptop or on Visi. And sometimes, if we need to control, for instance, Visi's head, indeed the clocks need to be synchronized, and you need to use NTP date for that. So one of the computers, either the robot's computer or the laptop computer, is going to be like a server of the clock, and the other one will be a client, and you need to synchronize the clocks first. If they are synchronized, then everything should be okay. And we had these issues when computing TFs, because it was going to say that, oh, this TF data is too old, extrapolation into the past or extrapolation into the future. And that happens if both clocks are not synchronized. The other solution is, as you said, have internet connection on both, but that's not always possible. So if you don't have internet connection, you need to use NTP date or some other clock synchronization mechanism.
I don't know if that is also the problem. It says it's the IP assignment. So if you don't have, I don't know if you are meaning, typically when you have internet in some way, you just connect and everything works. Everything works because you get the IP automatically using typically the DHCP system, okay? And it might happen that if you have just two computers, you connect those and nothing happens, so you need to manually set the IPs, okay? That might be also the problem. So sometimes, typically when you go to any internet connection, you get internet, but under the hood you have lots of things happening. And one of those things is to have DHCP that assigns to your computer automatically an IP, and you also get the gateway and all of that stuff and name servers. But that is under the hood. When you just have two computers and you put a cable between them, you don't have that. You have to put manually your IPs. So you have that issue, and you have also the issue of timing. Mostly TF system is very, very sensitive to timing, and you need to synchronize those.
Okay.
Is that clear, Rodrigo?
Yes, thanks.
Okay. Any more questions? Okay, moving on. So another, so I'll just list a set of ROS facilities without any details. We are going to know more on some of these on the afternoon's class. And so another very useful ROS facility is the parameters. And the typical pattern is that you are developing your system, and it depends on some parameters. A bad choice, but sometimes very usual choice is to put those parameters inside your code, but you need to recompile everything every time you change your parameter, okay? And that pattern, I mean, it's not like, I mean, it does not make any sense when whenever you change a parameter to have to recompile your code. And also, if you can use data files for storing parameters, but you need to do that every time you do your program. So ROS parameters allows you to do that automatically for you. And so the parameters, ROS parameters, is a repository of parameters that they are stored in ROS core. Another functionality of ROS cores, besides being a mapping of who is which, is to have a database of values of parameters, okay? And so, and these parameters are to address that pattern that you have your software that depends on parameters, and you want to change anything, just need to relaunch your node until you get a new parameter after you set that new parameter, okay? So parameters are used a lot in ROS, okay? They can be loaded from files, so you can have all of your parameters inside a data file, and you can load it from the command line, okay? And the format is a YAML, so YAML is yet another markup language, so it's like XML, much simpler. That's why it's all yet another, okay? So YAML is it's a format where you just have fields and values. It has some hierarchy, but I'm not going into details. There is a way to dynamically update these parameters, and your software can react in real time to change of parameters. And you have a command line utility called ROS param that manages everything. This is an example of a set of parameters, okay? So course name is the string. You have robot1, you have the name of robot1 Calvin, height of robot1 0.5, and this for robot2. This is an example that you can have this in a hierarchy of parameters. So you can have multiple robots, each one of those with different parameters. So that's really that's cool. And here is an example loading the parameters from a file. So it gets parameters from the file and loads it into ROS core. ROS param lists the files. Notice here how this hierarchy was reflected in the name of the parameters. We have this slash robot1 slash height, was this height over here that went over there, okay? And ROS param get course name, and this is a way that you can from the command line. And of course, you can programmatically set and get parameters values, okay? Now, this allows me to introduce this concept of hierarchy in ROS, okay? So here you have robot1 has these subparameters, name and height, okay? And the way that ROS reflects this hierarchy is using this slash notation, okay? Slash is like the root. Here it's like the folder, so to speak. So it's parameter of robot1, and here you have the parameter name. And you can have multiple ones. So you can have robot1 slash head slash blah blah blah. So you can have a whole hierarchy, okay? And so here you can organize parameters inside robot1, okay? And there is nothing magic about this one, okay? So this is just a string, and the name of the parameter is this string, okay? The thing is that the way the string is created is based on this hierarchy, okay? And you, from robot1, when you launch a node in robot1, you have a programmatic way of only seeing the parameters of robot1, okay? Meaning that the robot1 and robot2, okay, they can have exactly the same program. The way that you launch them can allow you to have the node in robot1 to have access to one set of parameters, and the nodes on robot2 to have access to another parameters in a complete transparent way, okay? So the robot1 and robot2 does not need to know that the name of parameters are different. They just get those, okay? Now, this pattern of using slashes to divide an hierarchy, it's also used for topics and also used for nodes, okay? So you can organize your topics in slash something, okay? And so when giving an example of the Monarch project, what we used to do is we have multiple robots, and the topics of one robot were organized in slash mbot01, for instance, and all of those were there. All of the topics on second was slash mbot02, blah, 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 okay? So you can organize the topics that way, and you can have the software running on a sort of a folder way, okay? So for instance, for the robot1, okay, the nodes running on robot1 did not need to know that it was slash mbot01. When you launch those nodes, you can do that in such a way that they only see the topics inside robot1, okay, in the templated way. This is very useful. This way that to organize, it's very useful for big projects, of course, okay, when we have lots. And since it is so easy to make new nodes and to make new topics, okay, you can imagine that typically robots, they have tens and tens, if not hundreds of topics and nodes. João, Visi, how many topics? Do you know how many topics and nodes when you launch Visi full power?
I have no idea. Maybe I don't know really. It's too many.
Okay, but what, 150?
Maybe around that, 100 probably.
So when you have 100 topics, it's easy to imagine that if you don't organize those with a hierarchy, it can get a little bit complicated. Okay, it still works, of course, but it's for us humans, it's easier to manage it that way. Okay, and you also have the same thing for nodes. You can have node names organized in different hierarchies, and so, for instance, the nodes in robot1, they can have a different than the other one. Okay, so all of this hierarchy is very universal in ROS and allows you to organize the set of topics, services, of course, nodes, parameters in an hierarchy, and it's easier to manage. Okay, easier to visualize, but also who is using it, it's easier because, as I mentioned before, if you have the nodes can be launched so that they only have direct contact with the ones there. That's why this slashes, that's why, if I don't know if you notice, but in this example, I used slash XPTO, okay? It is not really necessary, but when you want to make sure that this topic is on the root of your hierarchy, we put the slash something there, okay? So I could have, so this slash is doing, in this example, is doing nothing over here. I could do ROS topic echo without the slash and it will get it because slash is in the root, okay? So any questions about these parameters? And also I took the chance to also introduce this hierarchy concept. Okay, moving on, another very useful facility is the launch files. Okay, so as João said, you have tens of nodes running in typical robots. So the VZ robot here from ISR does not make any sense to launch one by one. Okay, so how do you launch all of those? You don't use scripts, you use the ROS launch. So ROS launch is a facility that allows you to launch multiple nodes in an organized way. Okay. So launch files are files in XML. Okay, these files, they define the nodes that you need to launch, and then you just need to do ROS launch, name of the launch file, and it just create all of those nodes automatically for you. Okay, but it's more than that. It's much more than that. You can use this. So this XML file, the tags that you can use, there are lots of tags. Here is just a simple example. You can set arguments. So you can call ROS launch with some arguments, and this is definition of a default values of those. Okay. This is a parameter. You can set parameters to values. Okay. So in this case, you have one argument, which is the map. So this was in for the ISR cobot robot. So a long time ago, the purpose here is to define one argument with the default value. This is the YAML file that defines where is the map, ISR 8th floor version 5. See, I don't remember what it is, so it was a long time ago. And this allows you to specify files inside the package, okay? And so find scout maps will tell you what are the maps, where is this package, / the name of the file, okay? So you don't need to hard code here the directory, of course. And then the parameter sets a parameter map, which is a string to the argument map. And see here this way of specifying arguments. And this is host parameter file. You can from a launch file load a set of parameters from this file, which is in this scout config package. Okay. You can include launch files inside launch files. Very, very useful. So if you have a big problem, I don't know if that is the case of the VZ, but with the Monarch we use that, which is typical pattern is to have a small top-level launch file with includes, for instance, localization system, drivers, blah blah blah. Okay.
Yeah, it's the same for us.
It's the same. Okay. So typical pattern is to have a small top-level master launch file with a set of includes, and in those includes you have the subsystems of the robot. Okay. So you can do input. In this case, it's include AMCL, which is the localization system that comes with ROS. And here is how do you specify one node? It's the node, the name of the node, navigation, where the package where that name the node is, and this is the only counterintuitive thing is that the name of the executable, its type is called type. Don't ask me why, some historical reason, but this is the name of the executable. So this launch a node named navigation that lives in the package called navigation, and the executable is called navigator. Okay? And then here we have some parameters. So these are parameters that are parameters private to this node. Okay? You can have different nodes with different parameters if you want. And so the notation is to use this tilde to specify a private parameter, type, string, and value. Just to specify that I want to use fast marching as a guidance method, and the platform is an omnidirectional platform. Okay. And this is it. You can have multiple nodes, you can have all of that stuff, and this is very flexible. It's hierarchical, so you can have launch inside launch files, and it's used for all non-trivial ROS systems. And when you launch ROS launch, when you kill the ROS launch, it will kill everything for you. Also very useful. Okay, just do Control-C, everything is killed. More. When you launch, when you do a ROS launch, if there is no ROS core running, it will create one for you. Okay, so ROS launch will automatically create a ROS master for you. which means that launching a very complicated ROS system is as simple as doing a ROS launch, blah, 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 and it will create everything. It will create ROS core, it will create the drivers, it will create everything for you, okay? So ROS launch is ultra useful system, okay? More, yeah, any questions? Are there any questions? And I forgot to mention, so there are more I'm not mentioning here. So loading of parameters, remapping topic names. I mean, this is very cool, which is that you imagine that you have a topic, okay? The topic subscribes to, for instance, XPTO. I can go to ROS launch and tell you that, and tell to that node, subscribe to a different node. It will remap the topic, okay? You can remap topics, okay? This is very useful. It means that if you want to, you don't need to change your code. If you change the name of the topic, you can simply remap it on the ROS launch, okay? Very, very useful. Names, parameters, you can remap everything, okay? Multiple machine support. So you can have one ROS launch that launches nodes on different computers, okay? I don't know if you do that on VZ because you have multiple computers, right? If you have different ROS launches, depends.
Yeah, we usually don't do it a lot, but we have the files configured for that. It's to test in the future.
Okay. But so this is cool because you can launch in one machine and it launches nodes in multiple machines, and of course when you kill it, it will kill everything. So transparent. This works under the hood. This multiple machine is with the SSH. You only need to have SSH configured with the public key authentication, and it just works. It's amazing. And then ROS launch is the one that does all of this magic for you. Okay, moving on. If there is any question, just don't hesitate to interrupt or say something on the chat. I'll try to keep an eye on that. TF system. So TF, João mentioned it briefly. So the TF system is it's a framework that lives inside ROS that allows you to very easily do geometrical transformations in 3D. Okay, 3D means 3D position and 3D rotation. This is extremely useful, and I will try to convince you of that. Okay, so typically when robot has what is called a TF3, which is coordinate frames attached to points or sometimes physical objects, on the robot. So in this example, you have one laser rangefinder. You have the laser rangefinder is a rigid body. You can attach a coordinate frame to it, okay? And you can give it a name. In this case, laser link. Laser link is the frame of reference of the laser. And you can have the same for the robot. So in this case, the robot is climbing something. Typically, the base link is a name that is called the frame of reference attached to the body of the robot, okay? And then you have a transformation, which tells you where the laser is with respect to the robot, okay? And this arrow over here represents a coordinate transformation between these two Fs, okay? So the only thing that we have over here is the frames, which has names, and transformation between frames, okay? Everything is relative. No frame has a coordinate because there is no general frame of reference. Everything is relative, okay? So the only place where you have poses, positions, orientation is in transformation between links, okay? And these transformations, they make a graph, okay? And so in this case, you have a laser, a transformation between the laser and the base link. You can have a second, in this example, we have a second frame of reference, which is horizontal to represent what is the horizontal plane, okay? It is called base stabilized, and you have a rotation transformation between the base link and the base stabilized, okay? And then you have from the base footprint to the base stabilized, which is the height of the robot, basically. So the base footprint is a frame of reference on the same ground level. And then you have these two frames. These are not physically attached to anything, okay? The map is the global frame of reference of this TF, okay? But its map is just another frame. There is nothing magical about this frame. It's just name. It's called map, and for us represents the coordinate frame of the map, okay? And now in ROS, typically the localization system has this counterintuitive way. Maybe I will explain it later on, okay? Which is this ODOM frame in the middle, which is at first sight same time confusing, but I will try to convince that it is not so confusing after all. Okay, so here the take-home message is that you have a graph of frames, okay, and transformation between them. And the other thing that has coordinates are the transformation between frames. Okay, there is one constraint, which is cannot be any graph; it has to be a tree. Okay, and that is a constraint that has to do with ROS. Okay, so you can have one frame having transformation to multiple other frames, but you cannot have one frame that for each there are two transformations to that frame. Okay, that is not allowed in ROS. Okay, so it's a tree. Okay? It has also always to be a tree. Okay, now this is by itself is not much useful. The usefulness of this is that this TF system you can you define these edges on the tree. Okay, so you can publish. The term is called broadcast, right, João? So you broadcast transformations. These transformations are between two frames, okay, and they represent this arrow. And you can query any part of transformations. Okay, so you can publish. So this tree that you can see over here can be published by multiple nodes. So different nodes can publish different transformations to the same TF3. Okay, you can have multiple TF3s disconnected, no problem. So I could have a map 1, map 2, no problem with that. Okay, and they are disconnected. Every time you have one connected tree, okay, you can query any pair of coordinate frames in which order I want. So I can query what is your DOM with respect to the base with the laser link if I want, and it will do all of the computation internally. So internally to the TF system, it will do all of the chaining necessary. Oh, we are almost finishing. Gosh, it was fast. Okay, so we can query in order. So this is very useful. Another very important point is it is also used a lot, for instance, when you are publishing laser data. For instance, you have a laser rangefinder. The laser rangefinder drive is publishing data from that laser, and it is a good idea to include into the message the frame of the laser. Okay, so let me go back. So inside this header over here, you have one field called frame ID, which is where you can tell what is the frame where this data ranges is related to. Okay, which means that now imagine that if the laser data comes with the information of the frame, you don't need to tell the robot in any place that the laser is 10 centimeters to the right. Okay, it comes since the TF comes with the message, and once you publish this transformation, and you can do that from the launch file, the localization system will immediately know where that laser is with respect to the robot. This is very useful because you don't need to do a parameter file telling that the laser is 10 centimeters to the right or something like that. Okay, it can. So all of that geometrical information can come from the TF. And the take-home message is that everything that has to do with geometrical transformations and to relative positions inside, for instance, inside the robot or between multiple robots, you should use a TF because the TF will simplify the life for you a lot. Okay. And so I don't have much time, so just to tell you that this is a little bit confusing at first, is that we have the base frame is the frame of the robot, the map frame is the frame. Now maybe I will try to annotate something here. Okay, can you see this?
Yes.
So okay, thanks. So typically we have a robot. Okay, you put here your base frame or base link. Okay, you have your map over here. Okay, and you attach to the map another frame. Okay, now what happens is that typically mobile robots, they use odometry. Okay, but odometry or that reckoning, it accumulates error. Okay, and typically the way that it works is that the integrated odometry of a robot is published by a transformation from odom and the base link. Okay, this is published by odometry. Okay, if the odometry were perfect, this frame would be static. Since the odometry accumulates error, this odometer will start shaking a little bit. Okay, but the point line is that the integrated odometer of the robot is typically published in this transformation from here to there. Okay, what the localization does? The localization, as a localization system, estimates this transformation, right? But it does not publish this transformation. What localization typically does is to publish this transformation from map to ODOM, okay? Such that this transformation from map to ODOM is the one such that when composed with this transformation will give you the estimation of where the robot is, okay? So what typically localization systems do in ROS is to publish a correction to the odometry, okay? Such that when you want to get where the robot is, you should query the basal frame with respect to the map, okay? Why this is so? This is a little bit counterintuitive, but it has a huge advantage, which is typically this transformation here from map to ODOM is published on the rate of localizer, okay? I don't know, I mean, AMCL, it publishes like 2 per second, something like that. If you want to control the robot, having localization 2 per second is not useful, okay? So, but since we are composing this with this one, okay, and since odometry typically is published like 20 Hz, 30 Hz, during 2 time instances where the localization published a message, you have an updated localization by the odometry, okay, and that allows you to do control in a easy way, okay. So using it this way, you have the localization system publishing this transformation. We have the odometry in a slower rate. You have the odometry being published almost in real time, so that when you query this transformation, you get real-time updated data. Okay. Now the difference is that during 2 updates of the AMCL, you accumulate drift. Okay. But the thing is that you can do closed loop control of robots very easily this way. Okay, so that's why we have this not so intuitive arrangement of this ODOM frame. I don't know, João, if you I don't know if you plan to show them this. If you see this happening on real time, it will be much more clear how this works. Okay.
I can try to show it. I'm not sure if we are going to have time with all.
Okay. Maybe next time we do a multi-day workshop.
Yeah.
Okay, let's move on. So I don't have much. We are past the time. Sorry about that. I don't have much material. Just to tell you that RVs, João will tell you about that. RVs is a super useful program to visualize data. And in this example, you can see in the RVs camera image from a camera. You can visualize 3D data. You can visualize the robot 3D model placed where the robot thinks it is. Okay. You can visualize the map over here. This is unoccupied grid map. So this is free space, black is occupied space. You can visualize the laser data in red, okay? And you can visualize these cost maps that are created by the navigation system. All of these on the same interface, okay? So very, very useful for debugging. And this is possible because all of this data uses a TF, okay? It is because these messages that are shown here visually, they have TFs attached, that you can visualize this, because otherwise you could not, okay? So this is very, very important, okay? But this is just visualization, okay? You have Gazebo, which is a simulator, okay? This simulates robots, and the Gazebo is split into a server and a client. So server is the program that actually runs the Newton-Euler equations and does the rigid body simulation, okay, of robots with contacts, with forces. So it's a dynamical simulator. And then you have the Gizzy client, which is the visualizer, okay. Of course, you can run Gazebo headless, which is just a server, if you want to save time. One typical pattern, for instance, if you go for the NASA Astro B, which is a robot in ISS, if you download the NASA Astro B simulator, you will see the Gizzy server only, and you use the RVs for visualization, which is faster than using the Gizzy client, okay? When you launch Gazebo without anything, it will launch both for you. But it's harder for you to know which one is it. I'm going to skip this. So this is just an internal view of what is Gazebo inside. So it is a multi-body simulator. It represents bodies with inertia, with collision, with the visualization. It implements sensors. It implements joints if you want to do a multi-body robot. It implements wheels, of course, and all of that stuff for you. Okay, I don't time for going through this. So Action Lib allows you to launch actions. The pattern is I want the robot to start doing something, and then I want to tell him to stop. This can be achieved using this Action Lib in a very, very easy way. So Action Libs gives you guarantees that the action was started, even though under the hood it uses topics. Okay, and so you can start something, you can stop, you can preempt. So lots of flexibility in Action Lib. So I advise you to look into it. I'm going to skip details, of course. You have a package, all of this is standard. You have a package to implement state machines, which is easy if you want to coordinate multiple behaviors. And it is the advantage of SMAC is that it is tightly connected to the ROS, which is very easy to have states in your state machine, monitoring topics, calling through the Action Lib some action. It's very easy to set up using SMAC. And you have more than finite state machines. The SMAC, even though it's called standard state machine, it implements you can run multiple settings at the same time with the concurrence, and you can do all of that stuff. You can have an hierarchy of state machines. You can have mixed with concurrence of multiple things running at the same time. Okay, it's very, very, very flexible, way beyond what state machines from the computational model allows you to do. Okay, and finally, just a very brief overview. Gmapping is for creating occupancy grid maps from laser data. So you can just run Gmapping and create a map of your environment out of the box of ROS, no programming necessary. Cartography allows you to do 2D or 3D maps. AMC allows you to, out of the box, localize your robot once you have the map, okay, out of the box. Move base allows you to move your robot from one point to the other out of the box. Well, not really out of the box, so sometimes you need to fine-tune move base. I don't know what it is these days, but in the past it used to be a little bit cumbersome to fine-tune parameters for the move base. But João,
still is.
Okay, so move base still is a pain to make it work nicely in the robot. Move it for robotic arms. Octomap creates 3D maps from RGB data. So RGB data is depth cameras. And ROS plans integrates classical planning from AI into ROS ecology. And we have many, many more. So this is just a very, very brief overview. Okay. And this is the last slide I have for you. I will just pause a little bit for questions. Sorry for passing a little bit over the hour. Okay, 7 minutes. Do you have any questions about this part of the course? I forgot something. I have a poll. Okay, very, let me go through very quickly. Let me see. I have a poll for you. Okay, so share screen. Okay, can you see the slide? It's not a slide. It's a. So go to this webpage, menti.com. Place this code over there and answer this question. A message in a topic originates from a publisher, a subscriber, a client, or a server. Of course, this is anonymous. Nobody is no one is collecting the. Okay. Okay, I think that's too easy question, right? So too easy question. I hope your questions are harder, Ron. Okay.
Not really.
We have lunch time to correct that. You know, go to lunch and make a little bit more harder. Okay, very good. So all of you got that it is the publisher is the entity, is role that publishes data to a topic. So thanks for answering. I have just one more question, which is, if I'm able, okay. So Gazebo is a visualizer of data, is a physics simulator, is a perimeter database, or is it a finite state machine? Not harder, to be frank, just to, okay. Too easy, okay. Okay, next edition of this course, I have to make harder questions. Okay, so sorry for being over time. So we will stop here for, unless there are any questions. You can make questions, of course.
I have just one question regarding the afternoon presentation, which was I wasn't able to correctly install the virtual machine. However, I already have Linux distribution with ROS installed. I just want to know which packages will we use. Is it only the Husky Gazebo?
João?
Yeah, it's only the ASCII Gazebo.
Okay, okay. Then I'll install it now during lunchtime. Thank you.
I just recommend to the VM because then everybody will be in the same ground with the same conditions. But if you want to use your installed Linux, it's okay also.
Okay, okay. Thank you.
João, by the way, I also have something. So I tried to install it. So VMware is installed, but when I try to play the virtual machine, it gives me an error. It says something that my machine supports something, but we can discuss that in the afternoon.
Okay.
I don't know if someone else got an equivalent error.
Can you paste that error maybe in the chat or so?
Sure.
Or maybe okay, I was thinking about creating a Discord where we can share all your...
And if you allow me, I can share my screen and I can show you.
Okay.
I can do that, Daniel. You can share if you want.
Okay, so do you see it now?
Yep.
Oh, I think you need to enable that in your BIOS. So you need to reboot your computer, go there, and then enable the virtualization options.
Okay, so this is not something from the. I thought it was an option here in the machine. So
I guess you can edit it in there to avoid using that. I'm not really know how. Maybe okay.
Yeah, because this is not ticked.
But I think that is inside. I think that is inside the virtual machine. If you want to enable virtualization, I think looks like the problem is before. It's whether the operating system allows the virtualization. Is that it?
Yeah, I think it's that.
Go to the BIOS.
No, I think it's the BIOS because you have some options.
It's probably some safety measures to virtualization.
So maybe reboot your computer, go to the BIOS, check the virtualization options, and maybe enable them.
Okay.
Because I think those options may actually, some are for safety measures, others are to actually make it faster because it depends on your computer. It might have some options to make virtual machines a bit faster.
Okay. Okay.
Yeah.
Okay.
So and let me know if it works or not.
Okay, I'll try it during the lunch break.
Okay.
Okay, any more questions before breaking for lunch? Just to notice that the Zoom ID is different. This is okay. So make sure you go to the web page of the course and you check for the new ID. We just did that this morning. So we were planning to do only one room, but then we decided to do different rooms, and so the ID is different. Okay.
And where is the ID?
It's on the Media Wiki.
Okay.
Maybe I can quickly go over there and I will paste on the chat the information. Okay, it's on the chat. The part 2 will be on this ID and password. Okay, so if there are no more questions, we'll break now for lunch, and we'll resume on that room at 2 p.m. Thank you for coming, and hope to see you all there. Take care and have a good lunch. See you.
Thank you.